Now let's understand how to measure the rate of reaction. First, let us calculate the average rate of reaction. In order to measure the rate of a reaction, the progress of the reaction is followed by studying the concentration of any one of the reactant or the product of different intervals of time. So when we consider a general reaction where reactants are converted into products, to calculate the average rate of reaction between any two instants of time, say for example T1 and T2, the corresponding concentrations X1 and X2 are to be noted from the graph. Let's see how. So this is the graph showing the time on the x-axis and the concentration of the reactant on the y-axis. So we want to calculate the average rate of reaction in a particular time interval. Let us say a time interval T1 and between T2. So at the time interval T1, we need to find out the corresponding concentration and which is equal to X1. And at a particular time interval T2, the corresponding concentration is equal to X2. So now rate is equal to change in concentration of the reactant upon time, isn't it? So that is equal to minus of X2 minus X1 by T2 minus T1. What is X2 minus X1? That is the change in concentration. And what is T2 minus T1? That is the time interval. Suppose for this particular numerical, X2 value is 0.01 and X1 value is 0.03. So the change in concentration, that is equal to 0.02. Then what is the time interval? Here the time interval is 15 minus 5. So that is equal to 10. So the answer becomes 0.002 mole later inverse minute inverse. So that is how we will calculate the average rate of reaction from the graph. Now let's see how to calculate the instantaneous rate of reaction. In order to calculate the instantaneous rate of reaction at any instant of time, suppose let me say it as t, we need to draw a tangent to the curve at the point corresponding to that time, and it's extended on either side so as to cut the axis. Then the slope of that particular tangent, that is equal to the rate of the reaction. Let me show you in the graph. So here again on x-axis we are representing the time in minutes, and on the y-axis we are representing the concentration of the reactant in mole per liter. So this is the exact graph. Now we want to find out the instantaneous rate at a particular instant of time. For example, at this particular time. So what we need to do, we need to draw a tangent. So this is the dotted line which is the tangent. So we need to draw the tangent to the curve at this particular point, and it is extended on either side to cut the axis. So this one up to this point here and this point here, given as A and B respectively. So then the rate of reaction, that is equal to the change in concentration upon time, which is nothing but equal to delta x upon delta t, and that value is equal to OA. This is the change in concentration. OA upon OB. This is OB. And this is nothing but equal to the directly slope of the tangent. So for instantaneous rate, the slope of the tangent drawn to the curve, that is directly equal to the rate of the reaction. So that is how we will calculate how we will measure the average rate and instantaneous rate. The same thing, here the only difference is the concentration of product is taken. That is the reason why I am circling the reactant in both the previous graphs. In the case of concentration of reactant versus time, the concentration decreases with the time. If there is a case of concentration of product and the time, it will be increasing. So that is the reason why here that shows the increase in the concentration of the product. So in both the cases, whether we express in terms of concentration of reactant or product, we will calculate the average rate in the same pattern, and the instantaneous rate will be equal to slope of the tangent drawn to the curve.